Have you ever pondered why Mars, a seemingly barren and arid planet, possesses the largest canyon in the solar system, suggesting a past brimming with flowing water? This is the Mars paradox, a riddle wrapped in the red dust of the fourth rock from the Sun. Look at the surface of Mars and you'll see the signs of a watery past. The most compelling evidence lies in the Valles Marineris, a Grand Canyon system that stretches across the Martian surface, dwarfing our Earth's Grand Canyon. This colossal chasm tells a tale of a time when water might have flowed freely on Mars, shaping and carving the landscape as it does on our own planet. And the story doesn't stop there. Scientists speculate that this arid desert was once home to vast oceans, expansive lakes, and meandering rivers, a world not too dissimilar to our own. Indeed, Mars, today's dusty and dry world, was once a water-rich planet. So, what happened? How did Mars transition from a water world to the desolate landscape we see today? Our story starts roughly 4.6 billion years ago with the formation of Mars. Just like Earth, the red planet was born from the dust and gas swirling around our young sun. As it grew, Mars developed a thick atmosphere and a magnetic field, essential conditions for liquid water to exist. Next, we move into what scientists call the Noachian period, named after Noach's Terra, one of the oldest regions on Mars. During this era, about 4 billion years ago, Mars was wetter and warmer. Water flowed freely, carving out valleys and filling up lakes and possibly even oceans. It was a time when Mars could have potentially supported life as we know it. However, a drastic shift occurred. Mars lost its magnetic field. Without this protective shield, solar winds started to strip away the Martian atmosphere. Over hundreds of millions of years, the atmosphere thinned, causing the planet's surface to cool. The once abundant water began to evaporate or freeze, locked up in polar ice caps and underground reservoirs. This brings us to the Hesperian period, starting around 3 billion years ago. This era was marked by massive volcanic activity. The eruptions occasionally melted subsurface ice, causing catastrophic floods that carved out channels. The water from these floods, however, quickly evaporated or froze. Finally, we reach the Amazonian period, a cold, dry era that started about 3 billion years ago and continues to the present day. With a thin atmosphere and no magnetic field, Mars can no longer sustain liquid water on its surface. The planet we see today is a frozen desert, with only occasional flows of salty water in the warmest months. Over billions of years, Mars underwent a dramatic transformation from a planet possibly teeming with liquid water to the frozen desert it is today. But what does this mean for us, and why should we care about the history of water on Mars? The legacy of water on Mars is far from being a mere chapter in the planet's history. It's a beacon of possibility, a tantalizing whisper of what may have been and what could be. The presence of water, you see, is a key ingredient for life as we know it. It's the lifeblood of our own blue planet, and its existence on Mars raises a thrilling question. Could this red desert have once been teeming with life? The search for signs of past or present Martian life is ongoing. Our rovers and probes are the detectives combing the Martian surface for clues. But the implications go beyond Martian microbes. The history of water on Mars also paves the way for future human exploration and habitation. The story of water on Mars, then, is not just a tale of a distant planet's past, but a stepping stone towards understanding our place in the cosmos and perhaps a glimpse into our own future.